Morning, everyone. I am Maria Cristina Reynera from MIT 503 Advanced System Design and Implementation under the class of Dean Marbella Abante, and I'll be discussing the Java programming abstract data types and implementations. So, for the first part of our session is to define first what is ADT. So, this ADT it refers to the data type that has values and operations that are not defined in the language itself. It is a specification of a set of data and a set of operations that can be performed on the data. Such a data type is abstract in the sense that it's independent of various concrete implementations. For example, all the Java's built-in types such as integers, doubles, or characters are all ADTs. You can declare variables of these types without understanding the underlying implementation details. You can initialize, modify, access the information held by these variables by specific operations. You can create your own ADT by using the class mechanism. On the next part of my slide, it says you can see it's a data structure is implementation from an ADT. In an object-oriented language like Java, an ADT and its implementation together make up a class. Each operation associated with the ADT is implemented by a member, functions, or methods. So the variable that defines the space required for the data item are referred to as data members. An object is an instance of a class. That is, something that is created and takes up the storage during the execution of the computer program. So now, what are the operations of the abstract data types? So we have four. So we have creator, producer, observer, and mutator. If we talk about creators, these operations primarily create operations of a certain type. However, note that some creators can take object as parameters too, but a creator will never take an object that's the same type as itself. For the producers, this is a sound familiar to the creator operations, but producers produce a different object of the same type. It does this by performing some kinds of operations of the objects and return a new object. So example of this one is when you merge two strings together, the producer method combines the two string objects and return a new object. For the third one, which is the observer, so these are the essential of the operations that can take an object on a single type and return an object on a different type. So for example, if you want to check whether the stock is empty, the function takes a stock object and returns a boolean value. And last but not the least is mutators. So mutators, these operations can change the object itself. This is evident when you add a new item on the list and change the object itself. So what are the abstract data types? So for these ones, we're going to define the different kinds of abstract data types in Java by using the collections. So Java library has an abstract data such as the list, stock, queue, set, map, and an inbuilt interfaces which are being implemented using the various data structure. In Java, abstract data types extends the collection interface which represents the data type. It is a part of Java collections framework and its root interface in the collection hierarchy. So the first ADT that we're going to discuss is what you call list. So it's a collection of the elements. It's a linear relationship with each other. So if they're going to define a linear relationship, it means that except the first one, each element of the list has a unique successor. So also the list have a property called the size. So which simply the number of the elements on the list. So list is mutable. This is also an interface where which means that other classes provided the actual implementation of the data. So these classes includes array list, which is implemented internally using arrays, and linked list if we're going to use it in a data structure. So the operations in the list ADT can be classified like the below in the examples, in the creators, producers, observers, and and mutators. Now, if we're going to look at on my next slide, so this is a sample of Java list, Java library list. So actually there are 25 different operations and methods, and some of the methods are the following. So we have the get, the insert, remove at, replacement, size, empty, is empty, and is full. So if we're going to define that one, for example, for the get, this method returns an element of a specific position. So for the insert, this insert element is used to uh, put the same type of as the rest of the list into the list. Note that you can insert the list in the element in any positions. Next, for the remove, so this method removes the first occurrence of the element in the array. However, the array has not to be non-empty. So we have also the what you call the remove at. So for the remove at is this element removes the element in a given position in the non-empty list. So the next one is to replace. This one is used to replace any elements by the given element in the list. So with the size also, we use the size. This returns the value of numbers of elements represent on the list. Then we have also is empty. It's used to function returns a boolean value to return if it's empty or not. And the last is the is full. It returns, or this function is similar to the empty function. However, it returns true if the list is full and false if it's empty. Now let's take a look of the first example. So this one an example on how to add elements to an array list. So we add elements to an array list by using add method. So this method has a couple of variation which can be based on the requirements. So what do you think is the output of this example? If your output is like this, you got the correct answer. So let's try to analyze this one. Of course, we're going to start first with the basic part of our program. So if you're going to look at it, in this the first line, the import is the Java keyword, which is used to importing a Java class or entire Java package. So if you want to import all the classes from any Java package, your import statement must be like like this one, which means it's an importing the entire Java. So in the next one, so we have the next line here is a template used to create an elements and to define the object data types and methods. So classes are categories and object are items within each category. So in our third line, as you can see, Java main method is an entry point of any Java program. So the keyword public static void main is the main by which this create the main method within a Java application. So it's a core method of the program and call all others. So it can return values and accept parameters for complex command line processing. So for the fourth line, so the fourth line is what you call or it's used to create an array list of a string type, and it cannot be used with any other kinds of lists such as the vectors, linked lists, and etc. So in the body part of the program, so the system will able to display the outputs of the following. So we have the Steve, Tim, Lucy, Pat, Angela, and Tom. Right? So, and you're going to notice that system.out is we use this one to display the components, right? So the system will insert the name of Steve in between of Lucy and Pat if we're going to use this one. Why? Let's take a look of it. So this index 3. So we know that if we're going to take a look of the commands. So since index starts always with 0. Right? So that's why if you're going to notice that index 3 would represent the fourth position and not number 3. So the output will come out now like Steve, Tim, Lucy, then Steve. So Steve is 0, Tim is 1, Lucy is 2, Steve is 3. That's why you will be able to see and apply the number 3 here. So that's the first example. So let's take a look of another example. So for example, number 2, this is how to remove the elements from an array list. So we use remove method to remove elements from the array list. Same as the add method, which method has a, a few variations. For example, what do you think is the output of this example? So if your answer is like this one, so you got the correct answer. So why? Because as you can see, the system will read the following elements. So Steve, Tim, Lucy, Pat, Angela, and Tom by using this one. Although in the next part, you will be able to see the remove command for Steve and Angela. That's why the next output will be, it will be Tim, Lucy, Pat, and Tom. So how come that it says here number two, and it still perform? Because this is what you call an index, right? So if you use this one, it will still run. So if you're going to look at it, let's go back with the ones that we mentioned, that index starts with 0. So if we're going to count it in on the list here, 0 it will be Tim, 1 is Lucy, 2 is Pat, 3 is Tom. So if it's 2, of course, we're going to remove Pat, right? Why Pat? Because team is 1, Lucy is 0, sorry. Team is 0, Lucy is 1, Pat is 2. Okay, so that's why on the last area, there's no Pat anymore. So let's have the last example. So I'll giving you the last example for this one. I hope you will able to understand more. So array list size. So we use that one to count how many elements are there inside. So basically we're using the size method of array list to find the number of the elements inside of the program. Now take a look at this one. So what do you think is the output of this program? If your answer is 4, you got the correct answer. Why? Because for this one, it will run the following elements. We have the apple, banana, mango, and strawberry. If we're going to count it, how many items are there inside? So it's 1, 2, 3, 4. That's why the answer is 4. So the array list, a list is created, as you can see, and this method is used to add the elements to an array list. So array list size returns the size of the array list, and that is the one displayed. Now let's take a look of the next ADT, what you call the stack ADT. So stack ADT is a collection of homogeneous data items or elements in which all the insertions and deletions occur at one end. We call it at the top of the stack. And the stack is a LIFO process, or last in first out structure. So when we're studying this, we came to know that the data are stored in the nodes of the data type. So in stack ADT, instead of the actual data, the nodes store pointers to the data. This structure also stores the count of the numbers of the elements, the maximum size of the stack, and the current node at the top of the stack. So the stack ADT managed mainly using two functions. We have the push and the pop. So the difference of the two operations, so the push operations adds an element at the top of the stack, while the pop operation removes an element from the top of the stack. So since the stack class extends vectors, so it is also grows and shrinks its size as needed with the new elements are added or removed. So what are the operations for the stack ADT? As you can see, it's the same, almost the same with the list ADT. However, we are using now the stack operators. Now, and of course, we're using also the method of vectors, but we still have the creators, producers, observers, and mutators. So you might ask, where can we use it, or can we translate it into real life application? So probably the first one is to a reverse word game. If you know that one, so because you push a given word to a stack, letter by letter, and then pop letter from the stack. Another example is the undo mechanism in the text editors that we're using right now, because this operations is accomplished by keeping all the text changes in the stack. So undo and redo stacks uses in word applications or spreadsheets or any applications that you're using to type informations. Then there's another one also, what you call the language processing, because the space of parameters and local variables is created internally using the stack compiler syntax. Check for matching braces is implemented by using the stack. Now, the function in a stack abstract data type, there are some functions that we need to know. And we usually use this one, the following. So push, pop, pick, size, and is empty. So if you say push, though, this function is very useful because you're going to push an element at the top of the stack. While the ones for the pop is you're going to remove the top element of the stack. We have also the pick, wherein this function returns the top element of the stack but does not pop it from the stack. So for the size, this returns the number of the elements present in the stack. And last is empty. As the name suggests, this function returns to the true if the stack is empty and the false if it's not. So let's take a look of the next next slide for the example. So as you can see, this one it was distinguished to use to identify that this one is for the stock. Now, for this one, in the stock string, so stock string, we use the word string for this one. Later on, I'll be discussing why we use this one. But if in this case, it creates an object of the stock class. Then when we use the animal dot push for the dog, for the horse, and the cat, we use this one to push the elements inside the stock. And we are going to use the system.out to print out the value of the variable, which is the animals. Now, in the next line, you are going to notice that animals.pop, because this one is we're going to use the pop element from the top of the stock. And after that one, we're going to print out the value of our variable. So the question is, what do you think is the output of this program? If your output is like this one, so stock, dog, horse, cat, then stock after pop, then dog and horse. So in the example, we use the word stock class, yes, to implement the stock in the Java. So for this one, so animal.push, so to insert the elements at the top of the stock. And we use the animal pop to remove elements from the top of the stock. Okay, so notice that we use also the angle bracket string while creating the stock because it represents the stock is for the generic type. Okay, so another example of the abstract data type is a QADT. So this type of ADT is a collection in which the elements of the same type are arranged sequentially. So the operations can be performed at the both ends, with insertion being done of the rear end, deletions being done at the front end of the single-ended queue. So technically, we're using the FIFO method, which is the first in, first out structure. So the design of this data type is similar to the stock data type that we saw earlier. So each of these nodes contains two pointers. So one to the data in it and the one for the next node of it. So the next one is these Java data structures like using linked list, concurrent, blocking queue, implemented internally respectively. So as you will notice, it's the same thing what we have from the link and also from the stock. We have the creators, producers, observers, and mutators, but the difference is the end part of the one that we're using, which is the following: linked list, as I mentioned, then concurrent and blocking queue. So here are some methods that we can use in the QADT. So first is we have the queue. It creates a new queue that is empty. So there's no need of parameters or return of an empty queue. So there's enqueue item, in which is this method is particularly used for adding elements to the queue. So these elements which are the new in the queue area are added to the rear end of it. So we have also the queue. So the queue is this function removes an element from the front of the queue and returns it. However, if the queue is empty, it does not return to the proper value. The next is empty. It returns a Boolean value based on whether the queue is empty or not. And the last is the size, to return the numbers of the items in the queue. And this function is no need for the parameters and returns an integer. So let's take a look of this example. So what do you think is the output of the program based on the following codes? If your answer is like this, you are correct. So technically, for this one, in this example, we use the queue interface to implement the queue in Java. So here we use the link list class. So for this one, this part that implements the queue interface. So the two parts of this one is the number offer and the number fall, which is additional functions in using the QADT. So for the number offer, so we use this one to insert elements to the rear of the queue, and the number fall is to remove the elements from the front of the queue. So notice that we use also the angle brackets that says here, like integer this one, because while creating a queue, it represents that the queue is for the generic type. So in this section, we're going to discuss on the scenarios to choose between either of the list, stack, or QADTs. So a list ADT is a collection of elements stored sequentially and can be accessed using their indexes. It needs to be chosen in cases which involves sequential or index access or removal of elements. So the use of the list ADT when there is a linear relationship between your elements. So lists also facilitate deletion and retrieval. So try to use that's your advantage. So this means that the lists are useful when you need to refer to each element in your collections by an index. So for example, various implementation of list ADT can be used to store data, and a list used in sorted order for an ordered or index access of removal. So since in the first data structure, the implementation of a stack ADT need to be chosen in scenarios where the most recent inserted elements need to be accessible first. So stack ADT are particularly used for redesigning and solution to the problems and need to delay latest process data first. Simply speaking, the stack data structure has a LIFO structure. Hence, you can use it whenever you see that you need to implement the recursive solution without using the recursion of something of that sort. So of the most common example where the kind of LIFO data structure is common is a function called stack of every programming language, where the most recent function is stack needs to be executed first. Queue is the first in first out structure and data structure implementing. So this kind of ADT needs to be chosen in scenarios where the elements need to be accessed in order of insertion. For example, where fairness needs to be secured. So QADT is useful when you need to implement some kind of discipline to the data in the collection. So, for example, if your data needs to be processed in order in which they arrive in the collection, so you can use queues. Operating system use queues for implementing scheduling algorithms. Another example of this one, or another scenario, is requesting handling by the web servers. So web servers facilitate the fairness to request handling according to their order of arrival by maintaining an internal queue for the request. So for our conclusion, so abstract data types are characterized by their operations. So operations can be classified into creators, producers, observers, and mutators. An ADT specification, it is a set of the operation and their specifications. A good ADT is simple, coherent, representation independent, and preserves its own invariants. An invariant is a property that is always true for an ADT object instance for a lifetime of the object. Invariants must be established by creators and producers and preserved by observers and mutators. Representation exposure, threatened by both representation independence and invariant preservation. Java interfaces help us to formalize the idea of the abstract data types as a set of the operation that must be supported by a type. With this summary, these ideas connect to our three key properties of a good software. First, same from the bugs. A good ADT offer a well-defined contract for a data type and preserving its own variants so that those invariants are less vulnerable to bugs into the ADT's client. And the violation of the invariant can be more easily isolated with the implementation of the ADT itself. Second, easy to understand. A good ADT hides its implementation behind the simple operations. So the programmers using the ADT only need to understand the operations not the details of the implementations. And the last but not the least, ready for change. Representation independence allows the implementation of an abstract data type to change without requiring changes from its clients. So before we end our session, so let's have a review about what we have discussed for today. So I'll be giving you 5 questions. All you need to do is to identify the correct answer. So number 1, which of the following is not an example of the abstract data type in Java? A, map, B, stock, C, set, D, long. So the correct answer is long, letter D. Number 2, it is a collection of the elements used to store the same type of data. A, array, B, case, C, function, D, loop. The correct answer is array. Number 3, if the elements A, B, C, and D are placed in a stack and are deleted one at a time, in what order will they be removed? Letter A, B, C, D. Letter B, D, C, A, B. Letter C, D, C, B, A. Letter D, A, B, D, C. The correct answer is D, C, B, A. Fourth question. Which of the following uses the FIFO or the first in, first out method? A, stock, B, queue, C, list, D, none of the above. The correct answer is queue. And last but not least, the fifth question, which of the following stores true or false data? A, integer, B, boolean, C, character, D, contradiction. So the correct answer is boolean. Okay, so with that, I would like to say thank you so much for listening and have a good day.